I want you to imagine, just for a moment, that you are walking past a newsstand. Or maybe you're just scrolling through the digital edition of a premier scientific journal.
Right, like one of the really heavy hitters.
Yeah, exactly. Think Science Magazine. Or a high-end, in-depth publication like Cosmos. Glossy cover, deep black background, and right in the center there's this bold text just dominating the page. And the headline simply reads, "The End of Brute Force."
It's a hell of a hook because it immediately demands your attention. It fundamentally questions the foundation of how human beings, interact with the physical world.
Right. And when you stop and really think about it, for literally all of human history, for centuries, millennia, all the way back to the Stone Age, our method for manipulating the physical world has been overwhelmingly, mechanical.
Yeah.
We hit things, we dig into the dirt, we burn fuel, we crush rock. It's inherently violent and incredibly wasteful.
Extremely wasteful.
But our mission today for this deep dive is to explore a really profound paradigm shift. What if we didn't have to smash or burn things? What if we could, in a way, sort of speak to matter?
Yeah, like having a conversation with it.
Exactly. What if we could adapt to the molecular properties of a physical object in real time and mold it without ever actually touching it?
And to answer that, we are looking at an extraordinary source document today. It's a highly detailed 2025 patent application, which was subsequently formalized and really expanded on in 2026 for a technological system called the CyberActuator.
The CyberActuator, which is our entire focus today. I have a stack of the schematics and the theoretical physics papers right here in front of me.
Yeah.
And my goal for this deep dive is to take you, the listener, through this dense, almost impenetrable engineering language and kind of translate it into a map of the near future.
This is dense.
Oh, it's basically a brick of math. But we are going to unpack how this cyber-actuator technology fuses quantum-like computing, metamaterials, and extreme-speed electronics into just this single platform.
And the applications laid out in this patent are just wild.
Unbelievable. We're talking about mining diamonds from deep underground without breaking a single rock. We're talking about building lunar bases out of moon dust without launching any heavy machinery into space.
Yeah.
We're even looking at the genuine physical creation of invisible force fields.
But, before we can even begin to look at those applications, we have to establish the context of why this hasn't been done before.
Right, the wall.
Exactly. We need to understand the fundamental wall that has stopped all previous engineering efforts dead in their tracks. The patent application refers to this barrier as thermodynamic blindness.
Thermodynamic blindness. I read that phrase in the introduction of the source material, and it struck me as such a strange way to describe a machine. It sounds like a medical condition, right?
It really does.
What exactly is the author pointing out here? Because they use this concept to call out a massive systemic flaw in almost all of our current industrial technology.
Right. So the document highlights a really severe functional divide in modern engineering. Today, our tools are split into two very distinct, completely isolated categories. On one side, we have probing tools.
Okay.
Consider ground-penetrating radar, or GPR, which geologists use all the time. These tools are purely observational. They send out a signal, they gather a massive amount of messy data, and then it takes hours, sometimes days, or even weeks to process that data through complex inversion algorithms.
Wow.
Weeks.
Oh, yeah, just to figure out what is buried underground, they only look.
So they can't actually change the environment. They just take a snapshot. And I guess that snapshot is often completely out of date by the time you've actually done the math on it.
Precisely. Now, on the other side of that divide, we have action tools. Think of a massive industrial induction heater used in metallurgy.
Right.
These tools only push. They blast out high-frequency alternating magnetic fields to induce electrical currents and, heat up conductive materials. But they are entirely blind.
Blind in what way? They do not analyze the environment in real time. They are programmed to just blindly dump a massive amount of energy into a predetermined spatial volume, simply hoping the target material absorbs enough of it to melt or bend.
So we have basically built a world of machines where the eyes have no hands and the hands have no eyes.
That is the perfect way to put it. That is the core of thermodynamic blindness. And the critical problem arises when you try to use these blind action tools to push energy into complex, heterogeneous environments.
That's dirt or mixed rock.
Exactly. If you are blasting electromagnetic waves into solid rock or trying to beam acoustic energy through layers of soil, you violently collide with what physicists call the impedance barrier.
I spent a good amount of time trying to wrap my head around this concept of the impedance barrier because, well, the physics in the patent gets incredibly dense right here.
Very
Let
dense.
me try an analogy to see if I'm translating this correctly. Imagine you were trying to have a highly nuanced, deeply emotional conversation with someone, but they are standing on the other side of a foot-thick brick wall.
Wow.
And to make the situation worse, you are wearing heavy noise-canceling earplugs. You are either just blindly shouting at the brick wall, using maximum brute force and hoping they hear something.
Induction heater.
Right. Or you are pressing your ear to the brick trying to listen to muffled, distorted echoes of the radar. You are never, ever having a real-time dynamic dialogue. The physical barrier prevents the actual exchange of energy.
The brick wall is a great stand-in for the boundary between two different physical media. In physics, when electromagnetic or acoustic energy travels and hits a boundary, say, moving from the air into a body of water or from loose topsoil into a layer of solid granite, there is a sudden, drastic mismatch in their impedance.
Impedance being?
Impedance is, at its most basic level, the resistance a medium offers to the propagation of a wave. Because the air and the water have totally different acoustic and electromagnetic resistances, a massive percentage of the energy you were trying to send across that boundary simply bounces right back at you. It reflects off the surface.
The source material puts a number on this, and it is staggering. It says 50% to 97% of the energy is reflected, up to 97%.
It's a huge loss.
So if I am operating a massive industrial drill or some kind of energy beam, almost all of the power I am paying for is just violently splashing back into my own equipment.
It scatters, it reflects, and it mostly just turns into waste heat. Current engineering attempts to fix this by using passive components. We build static tuning circuits, or things called quarter wave transformers, into our antennas to try and match the impedance of the target.
Do they work?
They do, but the problem is that these solutions are completely static. They only work for very narrow, highly specific laboratory conditions. If you tune your machine for dry soil and it suddenly starts raining, the soil's dielectric properties change instantly.
Oh, right, because of the water.
Exactly. Your static tuning becomes entirely useless, and you are right back to bouncing 90% of your energy off the mud.
So the machine is operating on a totally open loop. It's just guessing what the ground looks like.
An open loop, or a loop with feedback that is so agonizingly slow it might as well be open. You might have a thermal sensor that tells your induction heater it's overheating, but it takes seconds for the heat to transfer, for the sensor to read it, and for the software to throttle down the power.
And in computing terms, a second is forever.
In the world of electromagnetic waves, a single second is a geological era. Because of this massive temporal lag, the overall energy efficiency of traditional energetic systems is often sitting tragically around 3% to 40%. The rest is completely wasted.
That's insane.
Right. To truly cross the impedance barrier, the patent argues we need a system that doesn't just react faster, we need a system that is predictive.
Which brings us to the beating heart of the CyberActuator. The patent calls this core innovation the I-DPCM, the Intelligent Determined Cognitive Physical Closed Loop.
It's a mouthful.
I realize that is an absolute mouthful of engineering jargon. But what it represents is the merging of sensing the environment and acting upon the environment into one single, inseparable, continuous process.
The timeline of this I-DPCM loop is what shatters the current paradigm. The entire process of looking, thinking, and striking cycles in less than a single microsecond.
Less than a microsecond.
Yeah. The core mathematical inequality they base the entire patent on is that the cycle time of the machine must be significantly less than the relaxation time of the physical medium it is targeting.
Let's park right there. Relaxation time. I read this section 3 times. What does that actually mean when we were talking about a pile of dirt or a sheet of metal? I mean, dirt doesn't relax.
It is arguably the most important physical concept in the document. When you hit a piece of matter with an energy pulse, the matter does not react instantaneously. The laws of physics dictate a delay.
Okay.
It takes a tiny microscopic fraction of a second for the atoms, the electrons, and the molecular bonds within that material to shift, polarize, and form what we call reactive resistance. That structural delay is the relaxation time.
So it's like a lag in physics itself.
Exactly. If the energy pulse you fire is shorter than that material's relaxation time, you essentially catch the matter completely off guard. The matter physically cannot push back because its internal structure hasn't had the time to organize its defense.
This reminds me of being a kid at the local swimming pool. If I try to slowly push my open hand down into the water, The water simply parts, right? It moves around my hand.
Yeah.
But if I raise my hand and slap the surface of the water as fast and as hard as I can, it stings like I just hit solid concrete.
The slapping water analogy perfectly illustrates the inertia of matter. When you slap the water molecules are bound together by surface tension and hydrogen bonds. Your hand is moving faster than those molecules can physically get out of the way. You are experiencing the water's reactive impedance.
But the CyberActuator is doing the exact opposite of slapping the water. It is moving so incredibly fast that the concrete hasn't had time to harden.
Right.
The machine's energy is slipping through the cracks of physics before the water molecules even realize they've been touched.
By operating in what the text formally calls a super-relaxation regime, the device bypasses the formation of reactive impedance entirely. To achieve this, the hardware requires an absolute departure from standard computer chips. They are utilizing gallium nitride, or GaN transistors.
Okay, what makes gallium nitride so special compared to what we use now?
Traditional silicon transistors, which are in our phones and computers, simply cannot switch large amounts of power fast enough without generating so much heat that they literally melt. Gallium nitride has a much wider band gap, meaning electrons can move through it with vastly less resistance.
Oh, so less resistance means less heat.
Exactly. GaN transistors can handle massive power loads and switch completely on or off in under 10 nanoseconds.
I want to walk the listener through this timeline, because breaking down a single microsecond, which is 1/1,000,000th of a second, into actionable steps is where the science fiction becomes science fact.
Let's see it.
According to the schematics, the CyberActuator starts by firing a tiny, low-power probing pulse into the rock. That takes 20 nanoseconds. It then captures and analyzes the echo returning from the environment, which takes 100 nanoseconds.
Right.
It figures out exactly what kind of force it needs to apply to manipulate that rock, synthesizing a response in 50 nanoseconds. It physically reconfigures its own antenna array using those GaN switches in 10 nanoseconds.
And then the strike.
Finally, it blasts a high-power targeted force pulse for anywhere from 100 to 1,000 nanoseconds. It executes this entire sequence before the rock can even raise its impedance shield.
And that loop doesn't happen just once. It repeats millions of times a second. It probes, analyzes, adjusts, and strikes over and over in a continuous flow. Because it is operating significantly faster than the relaxation time of the rock, the effective impedance at the boundary drops massively.
So it's basically cheating physics.
It's certainly bypassing it. The source data shows that energy penetration increases by a factor of 2.5, not by increasing the brute force, but simply by outrunning the physics of the boundary.
Now, I am going to push back heavily right here. I was looking at these numbers, 20 nanoseconds to probe, 50 nanoseconds to synthesize a response. Light itself only travels about a foot in a single nanosecond.
It is incredibly fast.
If the machine is sensing, deciding, and reacting in a handful of nanoseconds, how can it possibly know what it is reacting to? You can't run complex decision-making software, evaluate environmental variables, and execute code in 50 nanoseconds. It sounds like the hardware is moving vastly faster than the software can actually think.
That exact bottleneck is the fatal flaw in traditional computing, and it is why no one has built this before. You cannot run a traditional computer program in 50 nanoseconds. Standard algorithms are deterministic. They require the computer processor to calculate every single possible variable one by one sequentially. Is the rock wet? Is it dense? What is the temperature?
Yeah, let's check all the boxes.
If you try to run deterministic math on a complex, messy environment like an underground cave, it would take a supercomputer seconds, if not minutes, to output a solution. By the time the computer figures out what to do, the environment has shifted, the relaxation time has passed, and the opportunity is gone.
I noticed the patent mentions a piece of hardware called an FPGA to solve this. I know what a CPU is, but what is an FPGA, and why does it let the machine bypass this software bottleneck?
FPGA stands for Field Programmable Gate Array. Think of a standard CPU like a very smart clerk sitting at a desk. You hand the clerk a stack of instructions, your software, and they read them one by one, doing the math as fast as they can.
Okay, sure.
An FPGA is entirely different. It is a blank canvas of raw logic gates. Instead of running software, you literally rewire the physical pathways of the chip to represent your algorithm. The math isn't being calculated by a program. The math is baked into the physical flow of electricity through the silicon.
Whoa, so there's no software?
Because there is no software layer to translate, an FPGA can execute complex logic at the speed of electricity moving through a wire. It is orders of magnitude faster.
But even with hardware that fast, how is it processing the sheer complexity of the environment? I mean, you still have to figure out what the dirt looks like before you blast it. You can't just wire electricity. Guess what a cave looks like.
This is where the patent introduces quantum-like fuzzy inference, or QFI, operating within a mathematical framework called a Hilbert space. The system abandons deterministic calculation entirely. It doesn't try to know the exact state of the environment. Instead, it builds what we call a digital twin.
Okay, let's spend some time on that. Because when I hear digital twin, I picture a 3D CAD model on a computer screen.
Yeah.
Like, an engineer looking at a wireframe model of a jet engine where the temperatures update in real time.
Yeah, that's what most people think of. But a traditional digital twin assumes it has absolute objective data about the environment. The CyberActuator's digital twin starts from a position of massive, blinding uncertainty. It utilizes the concept of superposition.
Wait, like quantum mechanics?
Now, the source is absolutely explicit about this. We are not talking about literal quantum entanglement. The device is not using subatomic quantum particles in a cryogenic freezer.
Okay, so it's not a quantum computer. It's just borrowing the mathematical architecture of quantum mechanics to handle uncertainty.
Exactly. In traditional computing, a bit is rigidly a 1 or a 0. In the system's Hilbert space, an environmental parameter is not a single number. It is a probability distribution of all possible numbers simultaneously.
That is wild.
Instead of the computer struggling to guess the one most likely state of the rock wall it just probed, it calculates a superposition of all possible states at once. The machine's logic essentially says, the rock is simultaneously solid, highly porous, completely saturated with water, and bone dry. I will prepare a mathematical energy pulse that is statistically optimal for all of those realities combined.
To bring this out of the theoretical math and into reality, the patent provides a brilliant practical example, scanning for a diamond buried inside wet rock.
It's a great example.
I want to walk through this because it helped the concept finally click for me. Let's say the CyberActuator is positioned underground, aiming at a patch of dirty, wet stone. In cycle 1, the very first millionth of a second, the system knows absolutely nothing.
Right. It's completely blind.
It fires a blind probe pulse. It receives a messy, distorted echo. The digital twin processes this in its Hilbert space and concludes, I have a 50% probability this is just wet dirt and a 50% probability there's a diamond hidden here. It embraces complete uncertainty.
The state vector in the math is in a broad, flat superposition. But the crucial factor is that the loop never stops. It fires a second pulse, but this pulse is adapted slightly based on the messy data from the first echo, then a third pulse, then a fourth.
And it keeps going.
Each individual time it probes the rock and measures the actual physical response against its predicted mathematical response. It calculates the error, uses that error to instantly tighten the probabilities. The superposition begins to collapse. The uncertainty shrinks with every single microsecond.
The numbers they provide for this collapsing error rate are breathtaking. By cycle 1000, which, if the machine is operating at a sluggish 100 Hz, only takes 10 seconds, the error rate has dropped exponentially to near zero.
Yep.
The superposition has fully collapsed. The system now knows, with 99.998% accuracy, the exact dielectric permittivity, the acoustic impedance, and the precise three-dimensional location of that diamond inside the solid stone. It mapped an invisible object almost perfectly, starting from zero prior knowledge in 10 seconds.
And it achieved that unprecedented accuracy precisely because it did not just passively listen like a traditional radar. It actively probed the stone, predicted the exact physical response, measured reality, and self-corrected.
It's constantly testing its own hypothesis.
Exactly. The source text makes a point to emphasize that this system requires absolutely no prior database. It doesn't need to be pre-programmed with the geological properties of an African diamond mine. It learns the environment out of the box.
This makes me think of trying to navigate a pitch-black room where someone is constantly moving the furniture around. A traditional machine just turns on a high-powered flashlight, but the light reflects off a mirror on the wall, blinds the camera, and the machine crashes into a table.
Right, because it only knows how to look in one way.
But the CyberActuator approaches the dark room completely differently. It takes a tiny microscopic step. It listens to the acoustic echo of its own footstep. It instantly calculates the probability of where the couch might be based on how the sound wave bounced. Within a few steps, the probabilities collapse and the machine can sprint through the dark room without bumping into a single object.
The predictive digital twin is the solitary reason the microsecond physical loop works. The machine knows exactly what high-power energy pulse to fire in 50 nanoseconds because the digital twin has already pre-calculated the probabilistic landscape of the room. The sensory brain and the physical brawn are perfectly, seamlessly synced.
We have established how the machine sees through solid matter, predicts the reaction, and slips its energy past the target's natural defenses. But what does it actually do with that energy? How does this device physically move matter?
This is where it gets really fun.
The patent application explicitly outlines contactless mining, which sounds like literal magic. Let's go back to that diamond. You know exactly where it is. It is encased in solid rock. How do you get a diamond out of a rock wall without touching it with a physical tool?
The document transitions from the cognitive digital twin into purely physical force mechanisms here. The device utilizes a highly coordinated combination of two powerful physics concepts, the Lorentz force and the ponderomotive force.
Okay, let's break those down.
To understand contactless mining, we need to look at the Lorentz force first. It is the physical force exerted on a charged particle when it moves through an electromagnetic field. In practical application, the CyberActuator uses its gallium nitride antenna matrix to project a highly specific, rapidly alternating magnetic field deep into the rock face.
I have to stop you there. A magnetic field. Rock isn't magnetic. A diamond certainly isn't magnetic. How does a magnetic field move a non-magnetic stone?
The material doesn't need to be magnetic. It simply needs to be slightly electrically conductive. And the host rock surrounding a diamond, which is typically a wet, clay-like rock called kimberlite, is full of water and dissolved salts. Therefore, it conducts electricity.
Oh, I see.
When the CyberActuator's rapidly alternating magnetic field penetrates this wet kimberlite paste, it induces what physicists call eddy currents. Imagine tiny, localized loops of electrical current suddenly swirling into existence inside the water trapped in the rock. Because these electrical currents are sitting inside the very magnetic field that just created them, they experience the Lorentz force. They are physically pushed.
So the machine is using electromagnetism to conjure microscopic swirling tornadoes of electrical current inside the pores of the wet rock.
It creates a distributed spatial rotor. Millions of microscopic turbulent vortices form inside the microscopic pores of the stone. This violent, highly localized microscopic movement fundamentally disrupts the internal friction of the clay particles holding the rock together. This triggers a phenomenon known in fluid dynamics as the thixotropy effect.
The thixotropy effect. I actually know the real-world application of this one. It's the ketchup effect.
Yes.
If you have an old glass bottle of ketchup sitting on a table, it acts like a solid. You can turn it upside down and it won't pour out. But if you smack the side of the glass bottle, the physical agitation causes the internal viscosity of the ketchup to drop drastically, and it suddenly flows perfectly like a liquid. It's a non-Newtonian fluid.
The ketchup analogy is exactly what is happening to the rock. The CyberActuator is electromagnetically smacking the kimberlite at a microscopic level. The source data notes that through this targeted Lorentz force, the viscosity of the solid kimberlite rock drops by an astounding 30% to 50%. It literally liquefies the solid rock immediately surrounding the diamond.
You have turned solid subterranean stone into a flowing liquid paste. But the diamond itself is still floating in the middle of that paste. How do you actually extract it?
This is where the machine introduces an acoustic element. It shifts its output and fires an acoustic pressure wave, specifically an acoustic chirp that rapidly sweeps through a range of frequencies.
Like a sonar ping.
Similar, yeah. Because the digital twin mapped the exact acoustic resonance of that specific diamond earlier, the chirp is tuned perfectly to the diamond's unique vibrational frequency. It gently vibrates the diamond just enough to break any remaining physical adhesive bonds with the surrounding liquefied rock. It pops it free.
And then comes the tractor beam. The patent refers to it as the ponderomotive force.
The ponderomotive force is a nonlinear force that pushes charged particles toward areas of lower electromagnetic field strength. But by manipulating the local dielectric permittivity of the fluid, which essentially means changing how the liquid paste responds to electric fields, the CyberActuator can reverse this physical effect.
Reversing it so it pulls instead of pushes.
Exactly. It creates a highly controlled electromagnetic gradient that physically pulls the dielectric diamond out of the liquid rock, moving it through the paste and into a collection filter. Total, complete, contactless extraction.
I'm looking at this whole process, creating intense electromagnetic microvortices, liquefying rock, shooting targeted acoustic waves, pulling with force fields, and I have to ask, doesn't that risk violently shattering the very diamond we are trying to save?
It's a fair question.
Because the whole problem with brute force mechanical mining is that crushers destroy a huge percentage of the diamonds before they ever see daylight. Aren't we just executing brute force on a microscopic level here?
It is a vital engineering concern, but the patent solves it through the system's absolute granular selectivity. Remember the digital twin we discussed?
Right.
The system identifies the specific spectral harmonic, the unique electromagnetic fingerprint of the diamond. Because a diamond is a dielectric material, an insulator, and the surrounding kimberlite rock is conductive, they react to electromagnetic fields in entirely different ways.
So they can treat them differently.
The system meticulously tunes the Lorentz force so it literally only affects the wet paste. The violent magnetic fields pass completely harmlessly through the diamond lattice without interacting with it. It is akin to using a powerful magnet to pull a pile of iron filings out of a sandbox. The grains of sand don't feel a thing.
That level of microscopic selectivity is what makes the technology scalable. Because the source text doesn't stop at an African diamond mine. It takes this core concept and scales it all the way to space exploration. They outline a massive scenario for lunar mining. Specifically, they detail the extraction of terbium, which is a rare earth metal absolutely crucial for modern electronics.
The lunar environment presents an incredible test case for the CyberActuator. On the surface of the moon, you obviously do not have groundwater to make a conductive paste. You have dry lunar regolith moon dust and a hard vacuum.
Totally different from wet kimberlite.
Right, but the underlying physics remain exactly the same. The source describes a scenario where a swarm of these devices lands on the moon, spreads out, and maps the lunar subsurface down to a depth of 50 meters.
50 meters deep, into solid moon dust and rock, just by pinging electromagnetic waves from the surface. I have to challenge the energy requirements of that. How much power does it take to blast a signal 50 meters into the moon?
Traditional radar would require an immense impractical power source to penetrate 50 meters of regolith. But remember, the I-DPCM loop outruns the impedance barrier. Because the swarm isn't fighting the reactive resistance of the moon dust, the energy penetration is incredibly efficient.
So it slips right through.
Once they map the terbium inclusions, they fluidize the dry regolith using resonant electromagnetic fields, separate the heavy rare earth metals using those ponderomotive forces, and extract it cleanly. The calculations in the patent claim they accomplished this extraction using 5 to 10 times less total energy than if humanity had to launch mechanical excavators, physical crushers, and toxic chemical processing plants to the lunar surface.
Use the word swarm. And this is the section where the patent shifts from describing a highly advanced tool into describing something that genuinely sounds like an artificial alien intelligence. The CyberActuator is not designed to be a lone, solitary device. It is built to operate in a massive, self-organizing swarm. The document officially designates this as Phoenix mode.
Phoenix mode is an absolute necessity for operations in extreme, isolated environments. If you deploy a group of autonomous robots deep underground or into the craters of the moon, they have to maintain communication.
Right.
But regular radio communication like Wi-Fi, Bluetooth, or standard aerospace telemetry fails miserably in dense environments. If you attempt to transmit a high-frequency radio wave through solid rock, dirt, or a thick plasma field, the wave is absorbed. You experience 60% to 90% signal loss almost instantly. The connection dies.
If Wi-Fi and radio waves cannot penetrate the dirt, how are these modules talking to each other when they're buried in a collapsed tunnel?
They utilize magneto-inductive, or MI, communication. Instead of broadcasting high-frequency propagating radio waves through the air, they generate near-field magnetic waves at a vastly lower frequency, typically between 100 and 500 kilohertz.
Okay.
Physics dictates that low-frequency magnetic fields penetrate dense physical media like rock, wet soil, and even salt water far more effectively than radio waves ever could.
But the trade-off for near-field communication is extremely short range, isn't it?
Yeah.
It's the same technology as tapping your credit card on a payment terminal. You have to be inches away.
The effective range for a single MI module pushing a signal through solid rock might only be 5 meters, but the system overcomes this limitation because they operate as a swarm. They daisy-chain the signal. Module 1 transmits to Module 2, which instantly relays it to Module 3, and so on.
Like a relay race.
Exactly. It forms a high-speed bucket brigade for data. A swarm of 10 tiny modules can spread out over 50 meters of solid granite and maintain perfect, instantaneous synchronization.
What exactly are they doing with that perfect synchronization? The source introduces a concept called a virtual supercore. If these units are chained together with MI communication, they aren't just sharing a map of the tunnel, they are actually sharing brain power.
They are networking their FPGA processors. If you have a dozen modules analyzing highly complex, chaotic underground structures, the processor in one single module might get completely overwhelmed by the mathematical load of its digital twin.
Sure, computing all those probabilities.
The swarm recognizes this bottleneck and automatically decomposes the computational task into functionally orthogonal subtasks. Orthogonal simply means the mathematical tasks do not depend on each other to be solved.
Oh, okay.
The overwhelmed module offloads fractions of the math to the available processors in the surrounding modules. They merge to form one giant distributed neural network.
The resilience of a distributed network like that is incredible. The text points out an emergent fault tolerance. Let's picture a catastrophic cave-in. A massive boulder crushes one of the modules right in the middle of the swarm.
A total physical loss of the unit.
Right. With traditional centralized robotics, the central brain is dead and the mission fails. At best, the system pauses for a lengthy reboot. Here, because of the probabilistic Hilbert space and the instantaneous MI communication, the swarm notices the loss of the crushed node in less than 1 millisecond.
Wow.
It dynamically redistributes the complex computational load to the surviving modules. The swarm doesn't even flinch. It just keeps mining with slightly less processing power.
And the Phoenix mode goes far beyond sharing data and processing power. They actually share physical energy. The modules are equipped with resonant inductive loops for wireless energy transfer.
Wait, they beam power to each other?
Yeah. If one module deep in the tunnel is burning through its battery, a neighboring module with a power surplus can wirelessly beam electrical energy to it. The system modulates the transfer at precisely 6.78 megahertz, allowing power to flow through the rock with an efficiency of 50% to 70%.
Consider the implications of that for space exploration. You could drop a dozen modules deep into a permanently shadowed lunar crater where sunlight hasn't touched the ground in a billion years.
Total darkness.
As long as just one single module is sitting up on the crater rim with a deployed solar panel, you can harvest the sun, convert it, and wirelessly beam that power down the chain module to module all the way to the bottom of the crater. It keeps the entire subterranean swarm alive indefinitely. The patent author literally refers to this capability as energetic immortality for the swarm.
That concept of deep space energetic sharing leads directly into what is perhaps the most ambitious logistical proposal in the entire document, the seed strategy.
I love this part.
This strategy is a masterclass in solving the brutal economics of space exploration. When an aerospace agency is launching mass out of Earth's gravity well, every single gram of weight costs thousands of dollars. You absolutely do not want to launch heavy metal equipment casings, massive parabolic antennas, or structural supports if you can somehow avoid it.
The seed strategy provides a radical alternative. Do not launch the robotic body, just launch the brain.
You only place the highly complex, infinitesimally small, micromanufactured components onto the rocket. The gallium nitride chips, the FPGA processors, the core sensors, these are the seeds.
Okay.
Once these tiny seeds land on the surface of the moon or Mars, they utilize local in situ resources, the raw regolith, water ice, trace atmospheric gases, to physically build the rest of their own hardware.
I read this and I honestly couldn't visualize it at first.
Yeah.
These seeds do not have robotic arms. They don't have mechanical grippers. How does a swarm of flat, microchip-looking devices pick up dirt and build anything?
They utilize a mechanism called dielectrophoresis, combined with the extreme microsecond electromagnetic control we discussed in the mining section. The swarm of seeds surrounds a pile of raw moon dust.
Right.
By manipulating the refractive index of the local space and creating highly specific targeted electromagnetic gradients in the vacuum between them, the swarm creates what are essentially invisible physical traps.
Invisible traps made entirely of force fields.
The nanoparticles of the moon dust are physically pulled by the strength of the electromagnetic gradient. They migrate through the vacuum, drawn toward the areas of maximum field intensity. The dust literally self-assembles in midair into the exact, complex, geometric shape the swarm's digital twin is projecting.
That is just wild to picture.
The swarm can force the dust to assemble into the protective shell for a new module, an intricate antenna array, or even massive human habitat structures.
The patent provides a specific, astonishing example of this terraforming capability. It outlines building a lunar base, specifically a 3 by 3 by 3 meter thick-walled radiation shelter for human astronauts. and the swarm completes the structure in 72 hours.
3 days.
The devices pull the moon dust into the shape of the thick walls using those dielectrophoretic force fields. Once the dust is suspended in the correct shape, the swarm fires highly concentrated, nanosecond plasma pulses that hit 1200 degrees Celsius. It flash welds the raw dust into a solid, impenetrable ceramic wall.
Unbelievable.
No wet cement, no heavy cranes, no human astronauts risking their lives in pressure suits. Just a swarm of electronic seeds projecting a building into physical existence.
If we step back and evaluate the philosophical implications of this, we are talking about functional terraforming. By exerting absolute control over the spatial and temporal modulator of the refractive index, essentially treating the physical environment itself as just another programmable variable, they can force matter to assemble or disassemble at will.
Yeah.
We are no longer designing structures and forcing them onto the environment. We are programming the matter of the environment to become the structure.
If you can program solid matter, what happens when you apply this physics to liquids or gases? The deep dive transitions here into a concept called transmedium transit. Basically, the ability to move a physical object between entirely different environmental mediums without experiencing friction. Imagine a massive nuclear submarine. When a submarine breaks the surface of the ocean to surface, it has to physically shove thousands of tons of water out of the way. It makes a massive, violent splash, and the engines lose a huge amount of energy just overcoming the surface tension and the sudden density change from heavy water to light air.
That boundary between the water and the air is a classic impedance barrier, exactly like the boundary between air and solid rock we discussed earlier. The sudden, drastic change in molecular density creates a physical wall of resistance. But the CyberActuator approaches this barrier not with mechanical force, but with anticipation.
As the object equipped with this technology approaches the surface of the ocean, it uses the predictive digital twin. It probes the water/air boundary 100 microseconds before the hull of the vessel actually touches the air.
Because the Hilbert space has already calculated exactly what the molecular boundary looks like, it prepares an energetic path. The system generates a localized cocoon of ponderomotive energy or plasma surrounding the hull of the vessel.
Like a bubble.
This energetic cocoon artificially grades the impedance of the water. It essentially manipulates the local physics to trick the water and the air into acting as if there is a smooth, gradual transition of density between them, rather than a sharp, violent wall.
It is the physical equivalent of an Olympic diver entering a pool perfectly, without a single drop of splash. But the CyberActuator is doing this from the inside out, going from water to air. And the patent claims it does this with less than a 5% loss in kinetic speed.
It's just staggering.
It slips out of the ocean like a ghost. And theoretically, if the physics hold, a vehicle could do this moving from loose sand into solid rock or from planetary atmosphere into the hard vacuum of space.
The mathematics scale perfectly regardless of the medium. If you possess the processing speed to control the local dielectric permittivity and the hardware to manipulate the friction via the secondary Lorentz rotor effect, the specific physical medium you are traveling through becomes largely irrelevant. You're mathematically isolating the vehicle from the environment's kinetic resistance.
Which naturally brings us to the final, and undoubtedly the most science fiction-sounding application in the entire patent. If you possess the technology to bend solid matter, and you can bend kinetic energy, it stands to reason that you can bend light. The source calls this lantern mode, and it outlines the creation of the ultimate active defense shield.
The concept of aerospace stealth is not new, but traditional stealth technology relies entirely on static physical geometry. Think of the sharp, radar-deflecting angled panels of an F-117 Nighthawk, coated in heavy, radar-absorbent paint. It is passive. If the radar angle changes, the stealth fails. Lantern mode is a dynamic, fully active stealth system.
It is actively continuously bending light and radar around the object in real time.
By dynamically controlling the refractive index of the atmosphere immediately surrounding the device, the swarm can physically bend incoming electromagnetic waves. Hostile radar pings, infrared heat signatures, and even the visible spectrum of optical light can be rerouted to travel smoothly around the object and continue on their original path.
That's basically invisibility.
It is exactly like the water of a fast-moving river flowing around a smooth stone. To an outside observer, or to a missile-targeting sensor, the object simply ceases to exist. The system sustains a controlled, programmable mirage.
That is mind-bending. But the document takes it a massive step further than just visual hiding.
Yep.
It details using this exact same technology as a literal physical force shield against kinetic attacks. The text lays out a scenario of a 6-kilogram wearable smart skin suit for personnel. Just 6 kilograms.
Incredibly light.
And it is controlled by a neuromorphic interface, meaning the suit's sensors are literally reading the operator's nervous system to switch modes instantly. I am highly skeptical of this. It reads like a video game.
It is absolutely written like a theoretical combat concept, but the author grounds the defense mechanism by breaking it down into 5 very concrete, mathematically verifiable levels of physics. Let's trace the exact sequence of events when a kinetic threat, let's say a standard high-velocity 7.62 millimeter rifle bullet, is fired at an operator wearing this suit.
Level 1. The hardware arbitrator. The suit's external sensors detect the incoming threat at a distance, but routing an emergency command through standard software takes too long.
Too much lag.
So the suit utilizes an FPGA hardware override. In under 60 nanoseconds, the physical logic gates on the microchip slam shut on whatever background tasks the suit was running and violently switch the entire gallium nitride matrix into combat mode. 60 nanoseconds. The bullet has barely left the barrel of the gun.
Immediately following that is level 2, plasma ablation. The suit's matrix projects an intense, focused electromagnetic pulse to the exact spatial coordinate in the air directly in front of the bullet's trajectory.
Wow.
It violently ionizes the oxygen, creating a microscopic layer of plasma burning at 10,000 degrees Celsius. As the bullet passes through this hyperheated plasma layer, the extreme thermal shock vaporizes up to 30% of the bullet's mass instantly.
It is melting a third of the bullet into a gas in midair before the metal even touches the operator.
The sudden vaporization of the metal creates a massive thermodynamic counterforce, an explosion of expanding gas that drastically slows the bullet's velocity. But the threat is not stopped yet. That remaining mass triggers level 3, the ponderomotive air cushion.
This is the invisible wall. The suit redirects its electromagnetic energy to rapidly compress the air in a localized space right in front of the physical impact point. It creates a high-pressure wall of solid air.
And it's powerful.
The patent states this air cushion generates 2,160 joules of stopping power. For context, the entire kinetic energy of a 7.62 bullet is only around 1,000 joules. The invisible wall of compressed air hits the bullet more than twice as hard as the bullet is traveling.
The vast majority of the kinetic energy is violently absorbed right there in the air cushion. But physics dictates that the kinetic energy must go somewhere, and the residual physical impact will eventually reach the suit. Level 4 addresses this physical contact. The outer layer of the smart skin is constructed from a thixotropic graphene shell.
The catch-up effect from the mining section, but applied to armor.
Exactly the same principle, engineered for defense. At the exact microsecond of kinetic impact, the intense localized Lorentz forces generated by the suit's matrix cause that specific microscopic point on the graphene shell to rapidly liquefy. It momentarily becomes a fluid.
That's brilliant.
A fluid is vastly superior at absorbing and dispersing kinetic shock waves across a wide area without shattering.
It absorbs the punch of the bullet like a pool of water, and then the very microsecond the kinetic energy dissipates, the Lorentz force stops, and the graphene instantly hardens back into a solid shell, effectively sealing up any microdamage.
Yeah.
It is self-healing armor.
And finally, level 5, verification. The system's digital twin runs a rapid diagnostic ping of the environment. In under 50 nanoseconds, it double-checks the spatial impedance map to confirm the threat is fully neutralized and the suit's structural integrity is restored. If the sensor detects the threat is somehow still moving forward, it instantly cycles back to level 2 and fires another plasma ablation.
I have to pause the breakdown here because, honestly, my credulity is being stretched. This sounds indistinguishable from comic book superhero armor, an invisible, self-healing, brain-controlled plasma shield. Is any of this genuinely feasible? We're analyzing a patent application from 2025 and 2026. Is this just an overly imaginative engineer writing a sci-fi novel and submitting it to a patent office hoping it sticks?
It is entirely rational to be highly skeptical of claims this grand. However, the document goes to great lengths in its final section, titled Industrial Applicability, to firmly ground every single concept in current reality. The author explicitly notes that the CyberActuator does not rely on hypothetical, uninventive, future metamaterials.
Oh, really?
Every vital component required to build this, the gallium nitride generation 7 power switches, the 3D printable graphene structural links, the silicon anode high-density batteries, the FPGA logic chips with built-in neuromorphic cores, all of these are explicitly listed by their real-world manufacturers. The patent notes they are either in pilot stage production or commercially available off the shelf as of 2026.
So the magic of the patent isn't a new miracle material. The magic is the integration. It's the I-DPCM loop. It's putting the predictive mathematical brain and the microsecond gain switches together so they operate fast enough to beat the laws of physics.
That is the ultimate synthesis of this entire deep dive. For the entirety of our technological history, humanity has suffered from thermodynamic blindness. We have fundamentally treated the physical environment as a passive, dumb obstacle that we must violently overcome with brute force. We push against the rock pushes back, and we waste 90% of our energy fighting the friction.
But the CyberActuator shifts that paradigm entirely. We are moving from blind brute force to a paradigm of absolute cognitive physical synergy. We aren't fighting the impedance barrier anymore. We're slipping seamlessly underneath it.
By perceiving the environment through the probabilistic lens of a Hilbert space, by operating physically faster than the structural relaxation time of atoms, and by actively using the environment's own conductive and dielectric properties against it, the machine stops fighting the world. It begins to program it.
And that leaves us with a truly wild, almost philosophical final thought to mull over. We started this hour by looking at a hypothetical magazine cover titled The End of Brute Force. We envision machines that don't hit or dig. But if you take a step back and think about what this technology actually implies, if a swarm of tiny electronic seeds can dynamically alter the physical properties of the air around you to stop a bullet in midair, if they can electromagnetically liquefy the solid granite beneath your feet to pluck out a diamond without a scratch, and if they can use invisible force fields to compel moon dust to assemble itself into a radiation shield,
it fundamentally blurs our definition of reality.
but where is the boundary between a machine and the environment? If the environment itself, the dirt, the air, the water, can be instantly reprogrammed by these seeds to act as a motor, an impenetrable shield, or a building material, the environment becomes the machine.
It's all connected.
The world around us becomes a programmable, physical extension of the tool. And if we take that thought to its absolute logical conclusion, what does that mean for the future of human habitation in the cosmos? As we expand outward, are we going to struggle to build rigid metal cities on Mars? Or are we just going to teach the Martian dust how to become a city?
That is the ultimate promise of overcoming thermodynamic blindness. We are limited only by the speed of our cognition.
It is an incredible, awe-inspiring future to think about. Thank you for joining us on this deep dive into the source material. It is a dense, mathematically mind-bending document, but is precisely the kind of technology that genuinely rewrites the rules of what is possible in our universe. Keep questioning the physical world, keep looking past the surface, and always stay insanely curious.